I think Mars is the hot destination right now, right? And I think the next big achievement in space exploration is going to be putting humans on Mars.
Even in the midst of the coronavirus pandemic, 3 unmanned spacecrafts from 3 different countries set off for Mars in July 2020. The United Arab Emirates Hope probe, China's Tianwen-1 rocket, and of course, NASA's Perseverance rover. All 3 took advantage of a particularly opportune launch window, when objects launched from Earth would have a shorter, more efficient path to Mars. The 3 missions will explore the red planet's atmosphere, map certain parts of its terrain, and collect surface samples for evidence of water and life, and do it in 3 different ways. Through these missions, scientists hope to understand how a planet like Mars can transform from a possibly habitable system with liquid water, organic material, and an energy source into a dry, dusty, and desolate place. So why the sudden race to Mars?
Life has been what is driving so much of Mars exploration, but there really is a lot more to Mars. And one of the things is that it has this fantastic rock record extending over billions of years, and no other planet has that. So if we want to understand even simple things about, how do Earth-like planets evolve over their first billion years, Mars is the place to do that.
Dr. Brianne Horgan is on the science team for the Perseverance rover, as well as a co-investigator on the MASS Kinsey camera system, which captures the stunning images sent back from Mars. NASA's Perseverance rover landed on Mars on February 18th in Jezero Crater, a 500-meter deep crater that was once home to a 1,600-foot deep lake. Scientists think a network of rivers probably fed into this site, making it a prime place for life to have evolved on the red planet.
And we can see that because when you look at Jezero from orbit, you can actually see this huge river channel cutting through the crater rim, flowing into the crater and creating a delta where it flowed into an ancient lake. That's where organic materials can be concentrated and preserved over very long periods of time on Earth, and so we're hoping to find the same thing on Mars.
Armed with multiple scientific instruments, including a pixel X-ray spectrometer and a RIMFAX subsurface radar, Perseverance rover has 4 main goals. Goal 1. Determine whether life ever existed on Mars. This mission focuses on surface-based studies of the Martian environment, with Perseverance seeking biosignatures in rocks that formed in an ancient Martian environment. A biosignature is any substance that provides scientific evidence of past or present life. Dr. Horgan, an expert in mineralogy, knows exactly what type of biosignatures the Perseverance rover may find on the Martian surface.
We can do things like search for, larger scale fossils that microbial colonies might leave behind in a rock. So textures, right, that look biological in origin. We can look for things like that.
Goal 2. Characterize the geology of Mars. Each layer of rock on the Martian surface contains a record of the environment where it was formed, like rings on a tree. Perseverance will search for rocks that formed in water and preserved evidence of organic materials, the chemical building blocks of life.
On Mars, there are, 4 billion-year-old rocks just sitting on the surface where they were deposited, waiting for us to come look at them. And it's entirely possible that some of those rocks could contain signs of how life started on Mars, which can then tell us about how life started on our own planet.
Goal 3. Analyze the climate of Mars. Mars's atmosphere, wind, and weather patterns also play a key role in analyzing if microbial life existed in the past. So NASA's Perseverance rover carried something big underneath its belly on its month-long mission to Mars to accomplish this goal. Something new to the red planet that's never been attempted before. The Ingenuity helicopter.
There's so many questions we want to ask that are kind of like just beyond the range of a rover. How did things in this region form? Or like, why did Mars have a magnetic field and when did it go away? Those kind of questions require much bigger spatial scales. And so a helicopter would be an absolutely fantastic way to do that.
Weighing less than 4 pounds, the Ingenuity helicopter was designed to survive in the harsh Martian environment after landing. Since there is a 20-minute delay in communication from Earth to Mars, Ingenuity has to fly independently without human control. And on April 19th, it did. Ingenuity successfully completed the first powered flight on another world, a historic moment and a major milestone demonstrating what's possible on Mars.
Yeah, so that video is fantastic because you can see the dust lifting off and then getting blown away, and it's actually getting blown away to the north, which is really important for understanding, how stuff is moving around the crater and where the sedimentary rocks we might be seeing right now, how they formed and where they came from.
And finally, Perseverance's last goal, to prepare for human exploration. NASA hopes to send a manned mission to Mars within the next 20 years. But human survival on Mars for an extended period of time comes with its own set of unique challenges. Mars's atmosphere is 96% carbon dioxide. Oxygen is less than 1% compared to 21% in Earth's atmosphere. Fortunately, the Perseverance rover has MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. MOXIE draws carbon dioxide and compresses it before passing it into what's known as the solid oxide electrolyzer, or SOXY. SOXY essentially takes CO2, which is 2 oxygen atoms and 1 carbon atom, and separates them. The separated oxygen ions join up to create a new molecule, O2, which is the oxygen that humans need to breathe. The CO, or carbon left behind, is essentially waste, but could be used to potentially fuel future vehicles on Mars. And on April 20th, the rover's 60th day on Mars, MOXIE successfully produced 5 grams of oxygen from the red planet's thin, carbon dioxide-rich atmosphere. NASA's Perseverance rover, China's Tianwen-1 missions, and the UAE HOPE probe are equipped with some of the most advanced scientific instruments to ever explore Mars. But with so many missions happening at the same time, is there a risk one of them could potentially harm the planet?
There's a whole field at NASA called planetary protection, and that's about trying to prevent us from contaminating other planets with life from Earth. When we take robots to Mars and we take humans to Mars, can we do it as safely as possible without contaminating the Martian environment? Especially because we don't actually know for sure that there isn't life living on Mars today, right? It very well could be. And so if we contaminate Mars too much, we'll risk kind of wiping out that unique Martian ecosystem.
But how likely is it that the rover will actually find evidence of life on Mars?
It's always hard to say. We're trying to answer a really big question that we have no idea what the answer is to. And I think if we can answer it either direction, that's a really, really big result. If we see zero evidence for any kind of microbial life, that's still a very important result that'll really help us understand, how rare and special life is in the universe.